So we have another method of solving non-homogeneous differential equations, which is known as the method of undetermined coefficients, MUC for short. MUC is applicable only whenever R of x is a solution to some homogeneous linear differential equation with constant coefficients. So given a non-homogeneous linear equation with constant coefficients, the general solution will always be the sum of the complementary solution and the particular solution. So in this case, we will find y sub p using the method of undetermined coefficients. So when there are no identical functions between y sub c and r of x, you may consider the following function for y sub p. So for example, for constant term, your y sub p contribution will be a, and then for polynomials you have a plus bx plus cx squared and so on. So let's say, for example, if you have let's say x, or rather ax, or 2 minus 3x, so both will have a plus bx. And then if you have, let's say, x squared, x squared minus 3x, or x squared plus 12, so both will have a plus bx plus cx squared. Okay. If there is a repetition of roots between the auxiliary equation and then your r of x, we follow the principles discussed in the homogeneous linear differential equation under repetition of roots. So for example, so suppose you obtain a complementary solution in the following form, and then this is your given r of x. Okay, so for C1, the root is 0, and then C2, C3xx e to the 2x, the root is 2 with a multiplicity of 2. So in r of x, we have e to the 2x, okay. The root is 2, also 2, and since we have repeated roots in auxiliary solution or auxiliary equation, then this will now be considered as your third root. Okay, and then for 2x, the root is 0, but it has a multiplicity of 2, but zeros already appeared in the auxiliary solution or complementary solution. So your first 0 here will be considered as your second root, and then this is now considered as your third root. So when you write down your y sub p, so e to the x, the root here is 1, so no identical root in the complementary solution. So you have e to the x, and then for e to the 2x, since this is the third root, you have to multiply by x squared. For the second root 0, you have to multiply by x. For the third root, you have to multiply by x squared. So that's how you write your y sub p for this case. So let's solve a second order differential equation using MUC. Okay. So the auxiliary equation, we have m squared plus m minus 2. So the factors are m plus 2 times m minus 1. So the roots will be 1 for m minus 1, and then here you have the solution negative 2. So for 1, this is your complementary solution for negative 2, e to the negative 2x. And then for r of x, let's start with 2x. If you have 2x, so the root is 0, but since that is multiplied by x, so you have 2, 0 here. So the corresponding y sub p is a plus bx. And then for negative 20 cosine 2x, your a here is 0. So b is 2. So the imaginary roots will be plus or minus 2i. And if you have plus or minus 2i, the corresponding y sub p will be c cosine 2x plus e sine 2x. So combining the two, your y sub p will now be a plus bx. Okay. C cosine 2x plus e sine 2x. Now, we have second order differential equation, so we get the first derivative. Okay. The second derivative. And then we substitute in the original equation. Okay. The next step is to equate the, after substitution, we equate the coefficients of similar terms. No? So this is your d squared y, this is your dy, and then this is your y. So substitute here, this is your d squared y, your dy, and then your y. Okay, so let's start with x. You have no x here. So we have negative 2bx, so the coefficient is negative 2b. On the right hand side, you have 2x here, so the coefficient is 2. And that gives you the value of b, which is negative 1. For a constant term, okay, you have b here. And then negative 2 times a, so negative 2a. And then on the right hand side, we don't have constant term here, so the coefficient will be 0. And then, since we already know b, substitute, and that gives you the value of a. For cosine function, this is negative 4c. You have 2e. And then negative 2 times c. Okay? And then, on the right-hand side, the coefficient is negative 20 for cosine. And then, that gives you negative 6c plus 2e equals negative 20. And then for sine function, you have negative 4e here, negative 2c, negative 2 times e. Okay? The right-hand side, we don't have sine, so therefore the coefficient is 0. And that gives you c e to the negative 3e. Substitute here. From the previous equation, we get the value of e, which is negative 1, c is 3. Okay. So, substitute the undetermined coefficients in your y sub p. Okay, so that gives you y sub p negative 1/2, negative x plus 3 cosine 2x minus sine x. And then we combine that to your particular, or rather complementary solution, okay, to obtain your general solution. Let's consider this third order differential equation, but this time this is an initial value problem. The initial conditions are given. So let's see how we get the particular solution. So we replace, this is d cube, no? D cube y. So we replace d cube by m cube, and then this is dy, replace d by m. So this is your auxiliary equation. Okay, and then we'll give you the roots. Okay, so for m0, m squared minus 1, square root of plus 1 minus plus 1 square root of plus 1 will give you negative 1 and positive 1. So for root, you have C1, for negative 1, e to the negative x, and then for 1, you have e to the x. Okay, and then your r of x for e to the negative x plus 3e to the 2x. For e to the negative x, the root is negative 1. That appeared already in your complementary solution. So you'll take this as the second root. So you have to multiply the solution by x. So your y sub p is ax e to the negative x, e to the negative x. And then for e to the 2x, your root is 2. It does not appear in complementary solution. So just constant, let's say b, and then e to the 2x. So combining the 2 will give you your y sub p. This is up to the third derivative, no? So we get the first derivative. Okay, we get the first derivative of y sub p. And then, okay, you apply product rule here, no? Copy ax, derivative of e to the negative x is negative e to the negative x, and then copy ae to the negative x, the derivative of x is 1. So derivative of this is 2b e to the 2x. You get the first derivative, and then the second derivative, and then the third derivative. Okay? Our original equation contains only y triple prime, no? So we'll be needing only this, and then your y prime. So we substitute in the original equation. So this is your y triple prime. This is your y prime. Okay. Now, let's start with e to the negative x. So you have 3a here. Okay. You have a times negative 1. Okay. And then on the right hand side, you have 4 here. And that gives you a equals 2. And then for e to the 2x, you have 8b here. And then negative times 2b, you have negative 2b. Okay, that's negative 2b. On the right hand side, you have 3. And that gives you b equals 1/2. So we only have 2 undetermined coefficients. No? So we substitute. Your a is 2, your b is positive 1/2. Okay. And then we combined y sub p to y sub c from the previous. Okay. So that's now your general solution. Now, since the initial conditions are given, we proceed to getting the first derivative. Okay. Up to the second derivative. Okay, up to the second derivative. So to solve for C1 and C1, C2, and C3. Okay, so let's start with the first condition, that when x is equal to 0, your y is equal to 0. Okay, so we substitute here. Your y here is equal to 0. Okay, so C1, e to the 0 is 1. Okay, e to the x is 1. When x is equal to 0, everything here will be 0. E to the 2x will be 1. So that will be C2 plus C3 plus 1/2. Okay? Simplifying, you get the first equation. And then, we get the first derivative of y. Okay? We get the first derivative. So this is the first derivative. Okay? Then substitute the initial condition when x is equal to 0. Y prime is negative 1. So from here, you have negative 1 is equal to negative C2, e to the 0 is 1. Okay, C3, this is 0. So plus 2 plus 1. Okay, e to the 0 is 1, e to the 0 is 1. And then that gives you negative C2 plus C3 equals negative 4 for your second equation. And then we get the second derivatives, or the first derivative of this. Okay. Then substitute the initial condition. When x is equal to 0, y double prime is 0. So you have 2 here. is equal to C2 when x is equal to 0, when x is, here e to the 0 is 1, so C3 plus C0 minus 4 plus 2. Okay, so you get C2 plus C3 equals 4. And as you can see, you can add equation E2 and C3 that will eliminate C2. And then your C3 will turn out to be 0, and then C2 is positive 4. And then we substitute C3 and C2 in your equation 1, and that gives you C1, which is negative 9 halves. Okay? And then we substitute, okay, in your general solution. This is your general solution. Your C1, no, C3, okay, so C1, and then this is your C2, no more C3, and then your particular, this is your particular solution, Y sub P rather. So this is your particular solution of your differential equation.